like they're not paying attention.
Correct. So the people who are paying attention, it's not a punishment because they should be able to answer the question quickly and accumulate points. But the other people who aren't.
What if the people who were paying attention just don't understand it? So that's the punishment too.
Then they should be asking questions to make sure they understand it. Okay, so let's look at this really quickly. Okay, as far as using your calculator, okay, again, the common mistake on calculator usage for this problem was what? Does anybody remember? Caroline.
Oh, it's not separating the X.
Caroline.
They forgot to either group the different parts of the thing. I guess a lot of people didn't do, and also didn't separate it.
Okay, right. So probably the main thing was this separating the variable x, y. You can't infer multiplication. You have to explicitly state that this is x times y. Nick?
I did that, and I got it wrong.
Yeah.
Well, I didn't say that's what everybody did. So there were other problems. Now, the comment that I made to most of you who did that was what? Do it in what way was that? By hand. Okay, Eileen, you can come here and sit in this chair. Okay. So, in doing this by hand, you should still be able to apply these properties, especially you guys have access to your notes. Okay. You should be able to apply your properties to combine all of these. Now, when you multiply two numbers with the same base, what do you do with their powers? Add them. So here you have an unwritten power of 1. Okay, so 1. So if you just take this whole value inside this fraction in the parentheses here. Okay. And in the numerator we have this base of x. Well, we have a power of 1 plus a negative 3. So we're going to add these powers. What happens when you divide two numbers with the same base? So we're going to subtract this power down here, so minus 2. Now, the y's we leave just as they are. So again, we can continue to rewrite this. What's negative 1 minus 3 minus 2? Get power of negative 4 over y to the negative 4. And again, if we wanted to, we could continue to write this. I'm going to come back to that in just a second. Let's say we take this fraction. Again, the order that you do things can vary slightly, but let's work inside the grouping symbols first so we can follow the orders of operation, which says do the grouping symbols or parentheses first. So inside here, if we rewrite this, still applying that power of negative 3, the numerator is just a 1, and here we have two numbers with the same base, so what do we do with their powers? Add them, x to the 1 plus 1. And then the y to the minus 2 will stay. We could rewrite this then as being 1 over x squared, y to the negative second. The whole thing applied power of negative 3. Okay, so what we can now do after we simplified our first step is apply the exponent. The exponent that exists here applies to all factors of the numerator and all factors of the denominator. So it applies to all three of these parts. So 1 to the negative third is still just a 1. X squared to the negative third, when you take a power to a power, what do you do with the powers? We not add. Adding is when you multiply. When you take a power to a power, you multiply. So 2 times the negative 3 gives you negative 6. And then the y is negative 2 times the negative, and negative 2 times the negative 3 gives you a positive 6. Okay, so here is this whole fraction simplified. Here is the first fraction simplified. So what you can do to solve this is you can just multiply these across. So you can approach this several different ways. And if you're doing it by hand, it may be easiest to turn everything into a positive power before you simplify. So x to the minus 4 can be rewritten. Put the x in the denominator, change its power. Y to the minus 4 can be rewritten, move the base y to the numerator, change its power. And then here, same thing. The x's have a negative power, so we can move them up. The y has a positive power, so we can keep it where it was in the denominator. Okay, and so if we take this here, and I'm going to move it over to simplify one final time, how many of these powers of 4 cancel with this power of 6? It leaves how many? 4 goes in, or 4 removed from 6 leaves 2. This 4 removed from this 6 leaves 2. So when I'm taking them away, it's just because using the properties when you divide, you subtract powers. So we wind up with an overall fraction of x squared over y squared. And then you evaluate it with the two numbers that your problem gave you. Okay. And so if you are evaluating that, remember I gave you 2 different ways to do this. So x squared divided by y squared. Okay. If you take this fraction and you want to evaluate it for x and y, you can either do them separately. So substitute in for x first. So according to this problem, 5.2. Go up, bring that whole solution down in terms of y, and then use the with key y equal to 2.5 as a separate step, and that gives you your answer. Or you can take your whole original value and solve for x equals 5.2, and then use the alpha lock space. You need the word and, A and D, space, y equal to, unlock the alpha keys, 2.5. So you can evaluate it with both of these. You just need to separate with the and you'll get your same answer. It asks you to round it to the nearest hundredth, which is 2 decimal places. So 4.33 would be the rounded answer for this problem.